Hi everyone, and welcome back. This tutorial is going to walk you through how to approach this question in practice problems 2. If you haven't read it over yet, please pause the video now and take a minute to read the question, then come back to see how we're going to approach it. What we have here is a question about enzyme activity. You're told that you took the same amount of enzyme and incubated it with different concentrations of the substrate lactose. You then measured the initial reaction velocity and obtained the data shown. Part A of this question asks, why is it necessary to specify that product concentrations remain negligible during the course of the reaction? To answer this question, I would start by focusing on the reaction that we're talking about here. In this reaction, lactose is converted to glucose and galactose. The thing is, this reaction, while it goes forward at the beginning when only lactose is present, if enough glucose and galactose build up, the reaction can also go in the reverse direction. So you want to measure the initial rate of the reaction before glucose and galactose have built up. This is because if product accumulation becomes significant, the back reaction may begin to occur, and the net activity in the forward direction will be correspondingly reduced. In part B of this question, you're asked to plot the rate of lactose consumption, or V, against the lactose concentration, S. In order to draw this graph, you want to take a look at the data that you have and make sure that the axes are labeled accordingly. We always have the substrate concentration on the x-axis because that's the independent variable, the one that you're controlling. We have the rate of the reaction on the y-axis because that's the dependent variable, the one that you're measuring. The concentrations that we used in our experiment ranged from 1 to 32 millimolar. So I'm going to have my x-axis go from 0 to 35 millimolar so that I can fit all of the data. When I look at the results that I obtained, the rates of lactose consumption that I found were between 10 and 44 micromoles per minute. So I'm going to have my y-axis be labeled to accommodate that, from 0 to 50 micromoles per minute. Now that I have my axes drawn, I can plot the points and obtain a curve that looks like this. Yours should look similar, although it might be a little bit different depending on how far out you went after the last data point that we had from the experiment. Next, we're asked to estimate Km and Vmax from our graph. Let's just take a quick look back at what those are. Here we have a sample graph of a reaction fairly similar to the one that we just plotted. The substrate concentration is on the x-axis, the reaction rate is on the y, and you can see that our curve levels out at a certain point when the substrate concentration is relatively high. This is the point at which we've hit Vmax. Vmax is important because once we know Vmax, we can figure out what 1/2 Vmax is, and that's the key piece of information that we need to find Km. Km is the substrate concentration at 1/2 Vmax, and it can help us understand how efficient the enzyme is and how well it interacts with the substrate. Now we can go back to our original graph and take a look at what Vmax and Km would be. Our graph doesn't quite level out the way the one on the previous slide did, so instead we can estimate Vmax to the best of our ability. I would say that it looks like our curve is starting to level out, but not quite there yet, and that we would level out probably around here, which I can estimate at 48 micromoles per minute. Given that, 1/2 Vmax is going to be 24 micromoles per minute, and I can use that to estimate Km. If I draw a line down where the two lines cross, I get an estimate of Km that's about 4. Now, I can go on to the next part of the question, which asks us to plot the results you would expect if each tube contained only 1/2 microgram of enzyme. For this, you want to recognize that the original results were obtained with 1 microgram of enzyme. With half the amount of enzyme, you expect the rate of the reaction to go down by a factor of 2. In other words, you would expect the rate of lactose consumption to be cut in half for each of the lactose concentrations that you measured. This means that you would get a graph that looks something like this. Here, we're told that we increase the apparent Km of the enzyme by a factor of 2. That means that instead of hitting 1/2 Vmax at 4 millimolar, we'll instead hit 1/2 Vmax at around 8 millimolar. Vmax is going to be the same as it was for the uninhibited reaction, although we'll have to go to a higher substrate concentration to reach it. We also need to cross through this point of Vmax over 2 and a Km of 8. This produces a curve that would look something like this. Given that we stopped drawing the graph at 32 millimolar lactose, We don't get all the way to the original Vmax, but if we were to continue to increase the substrate concentration, eventually we would find that it would plateau at the same rate as the uninhibited reaction.